I see there's another interesting question that came from the guest. I'll go to it. I've just got a follow-up question as well. I think from the earlier discussion, Eugene, you were talking about actual lime availability. I think you've mentioned a percentage of in South Africa, maybe in the region of 95%. Other areas or other countries, you were mentioning about 99%. That only says one thing, to say within that lime, there's some impurities or there's some foreign products which cannot be classified as lime. So then so my question is, in terms of the particle size and the grades, how does this influence the lime selection for downstream process? I think, Karsten, if you can go first on that.
I think that is a very, very important process or question, because you don't, in the sort of theoretical world, you get 100% pure lime. But if you actually mine the product, you do get lenses of, say, for instance, silica or something like that, that gets mined with the actual product. And when that gets burnt, the silica does not convert to quicklime, and then it remains a solid piece of rock, for instance. And if that's not ground down to very fine product, it remains in the process. So if you, for instance, use a slightly more coarser lime in your process, those coarse particles could actually be little particles of silica, for instance, which could damage your downstream process in terms of pumps, agitators, and that sort of thing. So it's very important to have a look at what is available in terms of lime, firstly, and what you're going to use it for. And because if we do use a coarser lime and we have to get rid of that grit, it obviously changes the equipment that's required for processing. So you really have to look at the application and have a look at what is available. And that's where the lime producers and we as Techmatic can get involved with making those decisions in the end as well, in terms of what is right for the application. Eugene, I think if you maybe just want to sort of elaborate on that as well.
Karsten, yes, thank you, and thanks, Prince, for the question. I'd like to just clarify one point in case I may have misled our listeners. Correctly, as stated by Prince, available calcium on limestone is about 95 to 98%. I think what is important to note, and I didn't state it, so my apologies, is once you've burned the limestone, the availability or the available calcium drops to anything from 85 to 89%. Now, you may say, why am I giving you a range? And that is because Mother Nature and burnt lime have a love-hate relationship. And that is, as you produce a burnt lime and it comes out of the kilns, if it's raining in the Northern Cape on that specific day, you will battle to continue having an 86% available lime, because Karsten alluded to this earlier on, the unslaked lime particle starts reacting with the water or the moisture in the air, which reduces your available calcium. If it's a dry, hot day, like it normally is, 89, 90% is quite achievable. So I just want to qualify that burnt lime is around, let's say on average, 87, 88%. But to the grit question, and I think that is for me one of the most critical parts of our industry that customers sometimes overlook. And I had the fortune and honor to be with a customer on site in the Northern Cape for a week late in February. And the young lady engineer, female engineer, spent some time with me, and she said, Eugene, I don't understand grit. And I tried to explain to her what Karsten just took us through. And she said, we've got this daily tonnage that we throw away. And I said, well, two things. Let me explain to you the Nesquik principle. And she said, what's the Nesquik principle? And I said, when you make milk, Nesquik for your kids, the strawberry one, and you pour it in their glasses, when they finish, what's at the bottom of the glass? She said, there's still a bit of Nesquik left. I said, that's grit. I said, so if you can take that Nesquik and just mill it a bit finer, and you pour it back in the milk, there will be nothing left. And that is why you should have fine, unslaked lime. Up to 600 micron is what we produce. There is no grit. And she said, Eugene, I now understand grit. As luck would have it, the next morning when we got back to the plant, there was no grit at the slaking plant. So fortunately, my Nesquik and the practice certainly showed one and the same answer. But I think the last point I want to make, Prince, and sorry to elaborate on this and carry on about it, but it's really about money. Within grit, and Karsten alluded to it, is really about 11%. So if you produce an 89% available calcium, there's 11% of insolubles. That is what it is. It's what Mother Nature gave us in the Northern Cape. However, in the grit, every ton that you throw away, there's up to 45, maybe 48% of available calcium that you're throwing away. And we've known that for many years. We test it. Whenever there's grit, we say, please, Mr. Customer, let's test it for you, or test it in your own laboratory. So you're throwing away up to 50% of calcium that you're paying 2,000 or 3,000 Rand for delivered to your plant. So grit I see as a double-edged sword. A, you have to throw away something that costs money in terms of removing it. And two, you're throwing away something that has available calcium, which you buy at the front end of your business to perform a certain task. So for me, finer is better is my motto. And certainly, if you can then process it, to Karsten's point, it will go through your process, no grit in your slaker, no grit in your holding tank, and you will not be wasting money. Thank you very much.